Lesson 10, the distributed property, part 2. There will be more practice on this. There is a part 3, which we will do on Monday, and then we'll do more practice on Tuesday. Alrighty, possible area. The rectangle has a width of 4 and a length of m. A width of 4 and a length of m. Write an expression for the area of this rectangle. Well, area is length times width. So we have m times 4 equals area. You could write it the other way. Area equals m times 4. It's just a different way of writing it. What is the area of the rectangle if m is 3 units? Okay, so we have, I guess this should be 4, and this would be 3. We would have 4 times 3, which is 12. All right, what if it was 2.2 units? So our length, I'm going to go ahead and change these ones so that they match up here. So this would be 4, and this would be m. This would be 1. All right, so for this one, area, length times width. 4 times 2.2 gives us 8.8, and I will double check that. 4 times 2.2, 8.8. Okay, for this one, 4 times 1/5. 4 times 1/5. Still using that ABC button to have my fractions. Our answer is 4/5. Could the area of this rectangle be 11 units? Why or why not? Okay, so we're going to go all the way back up to this equation because we're going to say we still don't know our length, but we know the area. So we have 11 equals m times 4. Well, what's the opposite of multiplying by 4? That would be dividing. And then m divided by 4 will give us a fraction. 11 divided by 4, or a decimal, gives us 2 3/4. So yes, the area can be 11 units squared. What were we missing? Length. Should be TH, sorry. Would be 2.75 units. Oh, sorry. There you go. All right, we're going to do more practice using distributed property and rectangles or squares. Partitioned rectangles when lengths are unknown. Here are 2 rectangles. The length and width of one rectangle is 8 and 5. The width of the other rectangle is 5, but its length is unknown. Write an expression for the sum of the areas of the 2 rectangles. Remember, sum means to add. So we would have that. So this one, we would have 5 times x plus, this one we would have 5, because if this is 5, I'm going to go with the same length, times 8. And then using the table from yesterday, we can use distributive property and rewrite this. 5 times x plus 8. Because this is 5 times the sum of x and 8. two rectangles can be posed into a larger rectangle. What are the width and length of the new rectangle? Well, my width is still 5. And the length is now 8 and x. And remember up here we added them. So when we're finding this whole length, we would add it. We would have x plus 8. Number 3, write an expression for the total area of the large rectangle as a product of its width and length. So that could be either one of these two. So let's write them both again. X plus 8. Actually, since it wants the larger one and we said it was x plus 8, we're going to go with product, which means to multiply, of its width and its length. 10.3. All right, for each rectangle, write an expression for the length and width and 2 expressions for the total area. Record them in the table. Check your expressions in each row with your group to discuss any disagreements. All right, so we have rectangle A, B, C, D, E, F. I'm going to do width as the heights of each of them, and the length is going across. So for A, my width is 3, and my length, oh, I should have made these longer, I'm sorry, is A plus 5. Right? Or area as a product of width times length. Sorry guys, I had a hair in my eye, or stuck to my glasses, tickling my eyelid. All right, area as a product of length times width. So product is multiplying. Length times width, so length, or width, times our length. Area as a sum, so that means we're going to add them. We're going to have 3 times A plus 3 times 5. Whoops, times 5. B. My width is 1/3. My length is 6 plus x. 6 and x. Length as a product, so that means we're going to have our parentheses. 1/3 times our length. X, sorry. And the next one, we're going to distribute it out and have the area as a sum. So I have 1/3 times 6 plus 1/3 times x. C. R. 1, 1, and 1. So 1 plus 1 plus 1. And they're using 1 because sometimes multiplying by 3s isn't the easiest. So 1 plus 1 plus, man, 1 plus 1 plus 1. So if we wrote it, we'd have R, 1 plus 1 plus 1. And when we distribute it to have an area of as a sum, r times 1 plus r times 1 plus r times 1. When you multiply by 1, you still get r. So it would be r plus r plus r. D. We have 6. Sorry guys, I don't like the pink. And then p plus p plus p plus p. 6. This is the same as 4p. Because the same thing as repeated addition is multiplication. So I wrote it as 6 times 4p, but you could also write it as 6 times p plus p plus p plus p. And then when we distribute, we would then have 24p because 6 times 4p is 24. But if we were to rewrite it this way, we would have 6p plus 6p plus 6p plus 6p. Well, since they all have like terms, the only letter we have in this is p. We would have 6 plus 6 plus 6 plus 6, which would be 24, or we would write out 24 p's. E. My width is m. My length is 6 plus 8. So we would have m, and then our parentheses 6 plus 8. If we were to rewrite it, we would have m times 6 plus m times 8. And then f, we have 5, and we have 3x plus 8. And I'm just going to rewrite it. So 5 times 3x plus 8. Rewrite it again. So they're individually 5 times 3x plus 5 times 8. That brings us to the lesson 10 summary. Again, we will have more practice on this, just so you know.